We've all heard of salt, right? Those white crystals we put on our fries are the kind of salt we are most familiar with. But what do we really mean in chemistry when we refer to something as a salt? In chemistry, a salt is an ionic compound which is made up of two groups of oppositely charged ions. The ion with a positive charge is called a cation, and the one with a negative charge is called an anion. How many of each type of ion the salt has is important because the compound must have an overall electrical charge of 0, that is, an equal balance between positive charge and negative charge. We'll cover more of this later. Salts can be easily identified since they usually consist of positive ions from a metal with negative ions from a nonmetal. The salt we put on our fries is actually sodium chloride and is made up of a sodium 1+, that's our metal, and a chlorine 1-, our nonmetal. Often you will see this written as Na+ or Cl-, the 1 is dropped, or simply NaCl. Before we can understand the glue that bonds ions together, we need to learn why certain atoms become ions at all. Ions are formed one of two ways. First, an atom can lose an electron to become a cation. Remember that electrons are negatively charged. So if an atom loses negative charge, it becomes positive. An atom can also gain an electron to become an anion. This happens because of the atom's electron distribution and the magic number 8. Chemists often refer to the octet rule, which, put simply, just means that an atom will achieve stability when it can get 8 valence or outer electrons. The atom will be similar to its closest noble gas in the periodic table. One way this can be achieved is by losing or gaining electrons to form an ion. We have already learned that metals form cations by losing electrons. For example, sodium is a group 1 metal, and like all group 1 metals, it has 1 valence electron. This electron is not held very tightly by the atom and is easily lost, which forms the sodium 1+ cation. Chlorine is a nonmetal and is found in group 17, or 7a, on the periodic table. It has 7 valence electrons, and it needs just 1 more electron to achieve the magic 8 for stability. Getting that extra electron will form the chlorine 1- anion. Notice that both ions, the sodium 1+ and the chlorine 1-, have the same number charge, just opposite signs. So what happens when a metal sodium atom meets a gaseous chlorine atom? A vigorous reaction occurs as both atoms form ions. The sodium transfers its extra electron to the chlorine. That gives the chlorine its magic 8 valence electrons and gives the sodium a positive charge. These ions are immediately attracted to each other, and the salt sodium chloride is formed. The ions are glued together by ionic bonds, which are the electrostatic attraction between opposite charged ions. The physical and chemical properties of materials are closely linked to how they are bonded together. We now know that ions in a salt are strongly attracted to each other, forming strong ionic bonds. It takes a lot of energy to break apart an ionic bond, and the stronger the attraction, the stronger the bond. This attraction between ions means that a compound with ionic bonds will have a strong, ordered structure. Salts often form a crystal structure or crystal lattice, a highly ordered formation of molecules. This is why we get crystals of salt on our fries. This ordered structure and strong ionic bonding leads many salts to have some special properties. First, they tend to be crystalline solids with crystal structures. The solids also tend to be hard and brittle due to strong ionic bonding throughout the crystal. Salts also have high boiling and melting points because it takes a lot of energy to break those bonds and change the salt's matter state. Finally, salts are electrolytes, meaning they dissolve in water to create free-moving ions, which are able to conduct electricity.